Hey guys, so in this video we are going to discuss two problems involving integration by parts. So let's start with the first integral, the integral of ln squared x dx. Okay, so we are going to use integration by parts here because we have two different kinds of function. We have ln squared x, which is a logarithm or logarithmic function, and we have dx, or it is 1 dx, that is algebraic. Okay, so 1 yung constant is considered algebraic. So we know that in integration by parts we have the integral of u dv is equal to uv minus the integral of v du. So how we are going to find the values of u and v? Okay, remember lie 8. So u will be the first. Okay, L is the logarithmic function, inverse trigonometric function, algebraic function, trigonometric, and exponential. So since we have Ln, then we have a constant 1, so 1 dx. So our u is equal to ln squared x. So we have let u equals ln squared x. Then what is the derivative of this? We have bring down 2, then ln x. Then derivative of ln x is 1 over x. So over x dx. Okay, then we have dv. dv is equal to dx or 1 dx. Then what's the derivative of v of dv? That is v. Derivative of dx is x. So we will substitute it here. So we have the integral of ln squared x dx equals u, which is ln squared x, times v, which is x. So we have x ln squared x minus the integral of v x, then du, which is 2 ln of x over x dx. So simplifying further, we have ln squared x dx is equal to x ln squared x minus, we'll cancel this, so bring out the constant outside the integral, is 2 integral of ln x dx. Okay, then how we are going to find the integral of ln x? Again, we will use integration by substitution. So we will let u be equal to ln x. Then derivative of ln x is 1 over x times dx, or dx over x. Then we have dv is equal to dx. Then v equals x. So we have the given integral ln squared x dx is equal to x ln squared x minus 2 times the integral of ln x dx is u times v, so ln x times x, so x ln x minus the integral of v, so x, then du, which is dx over x times dx over x. So we have ln squared x dx equals x ln squared x minus 2 times x, so 2x ln of x. This will be cancelled. So we have negative negative, so plus 2 integral of dx. Then lastly, we have ln squared x dx. Its integral is equal to x ln squared x minus 2x ln x plus 2 integral of dx is x plus c. So the integral of ln squared x dx will be x ln squared x minus 2x ln x plus 2x plus c. Okay, next problem is the integral of x squared sine x dx. So again, we will use integration by parts because we have two different functions here. We have x squared, which is algebraic, and sine x, which is trigonometric. So what will be our u? So from Lie8, so a first, algebraic before trigonometric. So therefore, we will let u be equal to x squared. Therefore, du equals 2x dx. Then dv equals sine x dx. So derivative of that will be negative cosine x dx. Or rather, negative cosine x. Okay, so the integral of x squared sine x dx is equal to u times v. So x squared times negative cosine. So negative x squared cosine x minus the integral of v. So negative, negative. So we have cosine x times du, which is 2x dx. So simplifying this further, we have x squared sine x dx equals, so negative x squared cosine x, so plus 2x cosine x dx. Okay, to simplify the integral x cosine x dx, we will use another integration by parts. Okay, so we have let u be equal to x. So derivative of that will be dx. Then dv is equal to cosine of x dx. Therefore, v is sine x. So we have the integral of x squared sine x dx equals negative x squared cosine x plus 2 times times the integral of x cosine x dx will be u times v, so x times sine x sine x minus the integral of v du, so sine x dx. Okay, so we have here, so the integral of x squared sine x dx will be equal to negative x squared cosine x plus 2x sine x minus, we know that the integral of sine x is negative cosine, right? Negative cosine times negative will be positive. So plus 2 cosine x plus c. Okay, so this will be the integral of x squared sine x dx.